Okay, today we're going to talk about something that you studied in high school, which you probably don't remember, and it's called difference of squares in cubes and perfect squares. So I'm going to show you how to derive most of this, so you won't have to memorize anything. Okay, let's get started. Okay, let's learn how to factor a squared minus b squared. And as you may recall from previous videos, I use a and b because a, b, and c represents constants in our standard equations. Okay, and c is the constant. A and b represents the coefficients in front of the x, and c is the constant. Okay, so let's see how we can factor a squared minus b squared. Let's say we have a blue square with all sides labeled a, and we cut out the part labeled b. So we have a blue square here. All sides are a. That side's a, right side's a, bottom's a, left side's a, and top is a. Okay. Then we measure out a distance called b, whatever that distance is, and we label it. Okay. So then what we do is we take a scissors and we cut out b. Okay. So now b is gone, and there's a space left in the blue rectangle, or triangle, or square. So now, what is a? Well, a is not there anymore. Distance a is gone on the top. So, what's the dimension? Well, the dimension is a minus b. And the dimension on the right side is a minus b. That's what the dimension is. And the bottom is a, and the top is, and the left side is a. Now let's draw a line between the intersection of the b's to the left side of a. Okay. Now, what we want to do is calculate the area of the blue remaining parts. Okay. Well, we see at the top the distance is a minus b, and on the right side is b, so the area of that side is a minus b times b. And we see that the rectangle on the bottom, the right side is a minus b and the bottom is a, so the area of that is a minus b times a. So there we have the area is equal to a minus b times a plus a minus b times b. Okay, and that's the total area of the blue that remains after we cut out the brown with the b. Okay, so then we multiply that through. That's a times a is a squared. A times minus b is a minus ab. Plus b times a is ab. And b times minus b is minus b squared. And if we add the middle parts, minus ab plus ab, that's cancels. And the area is equal to a squared minus b squared, which we were seeking to learn how to factor. Okay, but we haven't factored it yet. We've just figured out what a squared minus b squared is. Okay, so let's continue. Let's decipher a squared minus b squared. So let's cut the irregular blue piece into two congruent equal pieces with the black line. So we'll come from the intersection here, and rather than come straight across with the line, we'll come down to the vertex of the intersection of the A's on the left and the bottom. And then we'll cut that part out. Okay, and we know this part, this remaining region 1 and region 2, we know that this area is equal to a squared minus b squared because we just calculated that. Now, once we cut this, let's rearrange it and place the sides together like this, region 1 and region 2. We have a plus b on the top and b plus a on the bottom. And on the left, we have a minus b, and on the right, we have a minus b. Now, if we wanted to calculate this area, well, we would just say a minus b times a plus b, or a minus b times a plus b. Okay, and that's the area of this rectangle. But that's also equal to the area of a squared minus b squared. So therefore, a squared minus b squared is equal to a plus b times a minus b. And if you multiply this out, you'll get a squared minus b squared. So therefore, essentially what we've done is we've factored a squared minus b squared. We've factored it. Okay, let's continue. Factoring difference of squares. Okay. And that's what we were doing here. We were factoring a difference of squares. The difference means subtract. So a squared minus b squared. That's the difference of squares. Okay. So let's give ourselves an example. Let's say we have, and I'm using x instead of b, so you can differentiate between the formula and what I'm doing. But it could either be an x, a, b, z. It could be anything. Okay. These factors. So don't get confused by that. So we have x squared minus 25. Find the difference of squares. Okay. So we see what this is squared, and we see it's a difference. So we know we can use our difference of square formula. So we can change this to x squared minus 25 is equal to, how do we change this to our formula? Well, x, we can make that a, and 5, we can make that b. So x squared minus 5 squared, and 5 squared is 25. So that's the difference of squares. And x is a, and 5 is b. So all we have to do is plug in where a and b is, and we got our factor. Okay, so that's x plus 5 times x minus 5. So x squared minus 25 is equal to, factored is equal to x plus 5 times x minus 5. And if you multiply this out, that's what you'll get, x squared minus 25. Let's factor 48a cubed minus 12a. Factor out a common factor first, so let's do that. Well, what's a common factor in here? 12. 12 times 4 is 48, and a times a squared is a cubed, so that's a common factor. 12a times 1 is 12a, so that's a common factor, 12a. So what's remaining is 4a squared minus 1. 12a times 4a squared minus 1. Now we see, is this a difference of squares? Well, yes. 2, the square root of 4 is 2, and the square root of a squared is a. And the square root of 1 is 1. So therefore, we can write that as a difference of squares per our equation, okay? So we can say that 2a is 2a squared, and b is 1 squared. So we just take and plug in what our a's and b's are. A is 2a, so we put 2a there, and b is 1, we put 1 there. So therefore we have 12a times 2a plus 1 times 2a minus 1. And if we multiply this out, we'll get 48a cubed minus 12a. Okay. Let's continue. Let's factor 2x to the fourth minus 162. We're going to apply a factor technique more than once. This is just an example of what kind of equations you may come into contact with. So, okay, so let's factor out common factor. Well, 2 is a common factor. So 2 times x is to the fourth is 2x to the fourth, and 2 times 81 is 162. So we see 2 is a common factor. Now, let's change our difference equation to our difference of squares. Okay. X squared squared is x to the fourth, and 9 squared is 81. So now, according to our equation, our a is x squared and our b is 9. So all we got to do is plug in our a and b, and we have it factored. So we have 2 times x squared minus 9 times x squared plus 9. But now we see x squared minus 9 is still another difference of squares. Okay, so we have to apply our equation to that one also. So now we see that x is a and 3 is b. So we just plug in a and b in our standard equation, and we'll get 2 times x minus 3 times x plus 3 times x squared plus 9. And if we multiply that out, we'll come up with 2x to the 4th minus 162. Okay, let's continue. Let's factor 5x cubed plus 15x squared minus 5x minus 15. Okay, so here's our original equation, and let's factor out a greatest common factor, okay, which is 5. We can factor out 5 from each one of these. So that's 5 times x cubed is 5x cubed. 5 times 3 is 15x times x squared. 5 times x is 5x, and 5 times minus 3 is minus 15. So we see 5 is the greatest common factor. Now, what we're going to do is we're going to group our common terms. Okay? So we see x cubed and x. We group that with x. And we see 3x squared minus 3. We group that with 3. And this may take you a little time to figure out which terms to group together. But you'll come out with the same thing. So, okay, now let's factor again. Well, we factor out x cubed minus x, which is x. So we have x times x squared, which is x cubed, and x times minus 1 is minus x. So we factor out an x here. And what do we factor out on the other side? We factor out a 3, because 3 is common. So we have x squared minus 1. So now we see we have x squared minus 1 on both sides. So we can factor that out. If we factor out x squared minus 1, which is common, that'll leave us with x plus 3. Okay. So that's 5 times x squared minus 1 times x plus 3, which is factored out. The reason why is because if we multiply x squared minus 1 times x, it's right there. We had x squared minus 1 times 3, it's right there. So we can see that was a common group. Now we have a difference of squares we have to apply our formula to. And we see our a and b, our a is x and our b is 1. So we apply that to our formula, and we have 5 times x plus 1 times x minus 1 times x plus 3. Okay, let's continue. Before we go, I wanted to show you that here, where we grouped our terms, it doesn't matter if you can't figure out which one to group. One is easier and one is a little more work, but they both work out to the same answer. So if instead of picking x cubed minus x, you pick x cubed plus 3x squared with the first term, and minus x minus 3 for the second term, you still would have gotten the same answer. Okay. Let's continue. Numbers like 144, 16, 25, 49, 36 are perfect squares, since each can be expressed as a square of an integer. Products of the form a plus b squared and a minus b squared are also perfect squares. Okay. And so if you have a plus b squared, that's equal to a plus b times a plus b. And if you multiply that out, you get a squared plus ab plus ba plus b squared. and you get a squared. A plus b squared is equal to a squared plus 2ab plus b squared. And for a minus b squared, that's equal to a minus b times a minus b. And if you multiply that out, you get a minus b squared is equal to a squared minus 2ab plus b squared. Okay, let's continue. A trinomial factorable as a perfect square. So for a trinomial to be factorable as a perfect square, three conditions must be satisfied. The first term must be a perfect square. So you have 4x squared here. Well, the square root of 4 is 2. And the square root of x squared is x. So 2x squared is equal to 4x squared. So that's true. The last term must be a perfect square, which is, let's say the last term is 25 here. The square root of 25 is equal to 5. So that's true. And the middle term must be twice the product of the square roots of the first and last term. So 2 times 2x times 5 is got to be equal to 20. So 2 times 2 is 4x times 5 is 20x, and that's true. So therefore, this is a factorable trinomial as a perfect square. Okay, let's do an example. Determine if this is a perfect square and factor. So we have 16x squared plus 32x plus 64. Is the last term a perfect square? Yes, 64. 8 times 8 is 64. Is the first term a perfect square? Yes, 16. 4 times 4 is 16, and x times x is x squared. So we got the first and the last term. Let's check the middle term. Is the middle term 2 times 4 times x times 8? No, it is not. 2 times 4x is 8x, and 8 times 8 is 64x. And that's, in the middle term is 32x. So it's not 64. So therefore, it's not a perfect square. This trinomial is not a perfect square. But you can factor it. You can pull out the greatest common factor, which is 16. And now you're left with x squared plus 2x plus 4. Can you factor this? Well, the trick to knowing this is, look at the last term. What two terms can you multiply to get 4 and add to get 2? If you can think of a term that you can factor to get that, then you can't go any further. You would have to use the quadratic formula to factor this. Okay. Let's continue. Determine if a perfect square and factor. 9z squared minus 12z plus 4. Okay. Well, is the first term a perfect square? Yes. 3z squared is equal to 9z squared. Is the last term a perfect square? Yes. 4 is 2 squared. Okay. And is the middle term equal twice the first and last square root of first and last term? Well, let's see. 2 times 3z times 2 is equal to what? 12. And that is what the middle term is. So therefore, this is a perfect square trinomial. And now we can factor it. So, okay, what we do is, we do just what we did before. We take the first term and find out if it's a square, and we say 3z squared. We take our middle term, which we found out was 2 times the first and the last, square root of 2 times the first and the last term, which is 2 times 3z times 2, and we find the square of the square root of the last term, which is 2. So 2 squared. Okay. And we write this as according to our formula. A minus b squared is equal to a squared minus 2ab plus b. Well, what is a? Well, a is 3z. And what is b? B is 2. So we plug in our equation of our a and b, and our a is 3z and our b is 2. And there it is. It's factored. 3z minus 2. And if we multiply that out, we get our original equation. Okay, here's everything we've done. And I've written it out so you can look at it and review it. I'm not going to go through it, but it's here. Okay. Let's continue. Now we want to do something else. We want to factor the sum and difference of two cubes. Okay. And in high school, this is what we've learned. The sum and difference of two cubes. The sum of two cubes is a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. And in high school, they tell you, well, the first two signs are the same, and the next two signs are opposite signs, okay? And then the difference of two cubes is the same equation, just that you change the signs, okay? So the first two signs are the same, and the next two signs are opposite signs. This is the way the majority of textbooks teach you. This means you must memorize these equations. I'm going to show you how to derive these so that when you need them, if you forget them, you can derive them for yourself. And this is how I learned mathematics, of deriving what I needed. If it wasn't given to me, I was capable of deriving my own equation. And I got a deeper understanding when I learned how to derive an equation. And most of the time when I teach you mathematics, I'm going to derive the equations when possible, if it's not too confusing. Okay. Okay, let's get started. The sum of two cubes. Let's do the sum first. So let's say, and I'm going to use x and y instead of a and b, so you can differentiate between the two. But so let's say x plus y cubed. Let's start out with that. What is x plus y cubed? Well, that's equal to x plus y times x plus y squared, because we factored out an x plus y. Okay. Now, let's do the x plus y squared. Well, we know x plus y squared is x plus y times x plus y, right? Okay, now let's multiply that out. So that's x times x is x squared, x times y plus y times x is 2xy. I skipped a step in here. I shouldn't have done that. And then we have y times y is y squared. And now we multiply it through by the x plus y. So we have x times x squared is x cubed. X times 2xy is 2x squared y. X times y squared is x times y squared. Then we multiply by y. We have y times x squared is y times x squared. And y times 2x squared y is 2x y squared. I'm sorry. Y times 2xy is y times 2xy is 2xy squared. And y times y squared is y cubed. And you can see how confusing this gets. So, okay. And we add up our like terms. We have 2xy squared and xy squared. That gives us 3xy squared. And we 2x squared y and yx squared. And we add up our like terms. We get 3x squared y. Okay, now we can factor these two and move our y cubed over to the left. And we can factor out a 3xy. And that leaves us x plus y. Okay. Now, we have an xy on the other side. So, let's move this 3xy times x plus y to the left. Okay. So, we move that to the left. And now we have x plus y cubed minus 3xy times x plus y. Okay, so now we have x cubed plus y cubed. We have the sum of two cubes because we had x cubed plus y cubed on the right. So now we can factor out an x plus y. Okay. So we factored out an x plus y. Here, we factored out an x plus y. And now x squared, x plus y squared is equal to x squared plus 2xy plus y squared. So let's place that in there. And now we can add like terms. And we get 2xy minus 3xy. That gives us a minus xy. So therefore, we have the difference we have the sum of two cubes is equal to x plus y times x squared minus xy plus y squared. Okay, and as I said, I did my derivation in x and y so you can see to distinguish the two. But if I pull up the previous one with the a plus b, a's and b's, you'll see that the x is a and the b is y. Okay, so and they are the same. And that's how you get the sum of two cubes. Okay, and the first sign is plus. First sign is plus, and the second signs are opposite. Okay, and exactly the same, except that I use x and y instead of a and b. Okay, let's continue. Let's do the difference of two cubes. Okay, and the difference of two cubes, we have x minus y cubed. And we do the same as we did before. We factor out x minus y. And now we're left with x minus y times x minus y squared. And we know what x minus y squared is. That's x minus y times x minus y. Okay. So then we'll multiply that out. And we get x squared minus 2xy plus y squared. Okay. Now we multiply through by x minus y. Okay. And then we get x cubed minus 2x squared y plus xy squared minus y x squared plus 2xy squared minus y cubed. Okay. And then we can add our like terms where we have xy squared, xy squared. Those are like, so we can add them together. And we have x squared y, those are like, and we can add those together. Okay, and so now we get x cubed minus y cubed minus 3x squared y plus 3xy squared. And then now we can factor out x minus y. Okay, and we move our minus 3xy times x minus y to the left-hand side of the equation. That leaves us with x cubed minus y cubed, difference of two cubes on the left-hand side, and then we can factor out x minus y on the right-hand side. Well, if we factor out x minus y on the right-hand side, that leaves us with x minus y squared again. Well, we know what that is. That's right there. Okay. So we just plug that in here, x squared minus y, x minus y squared, and we plug that in, and we add the terms, and that gives us what we had for the factoring difference of two cubes, as we had before. X cubed minus y cubed is equal to x minus y times x squared plus xy plus y squared. And it's just like we had at the beginning of our video. We have a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Except that we use the coefficients here, okay? And a is x and b is y. Okay. Let's continue. Well, let's do some examples. Sum of two cubes. Okay. So we have 2x cubed plus 128y cubed. Okay. Well, we factor out a 2. So that's 2 times x cubed plus 64y cubed. Okay. Now, let's plug this into, let's make this look like our formula. Okay. So x is x cubed plus what's 64 cubed? Well, that's what's the cube root of 64, which is 4y cubed. Okay. So 4 raised to the power of 3 is 64, and y raised to the power of 3 is y cubed. Okay. So now we have what? The sum of two cubes. And here is our formula. The sum of two cubes is x plus y times x squared minus xy plus y squared. Okay. So what is x? X is x. And what is y? Y is 4y. So we plug in to our equation x and 4y, and we get we factor the sum of two cubes, which is 2 times x plus 4y times x squared minus 4xy plus 16y squared. Okay. Factor the difference of two cubes. Okay. The difference of two cubes, let's take the example 8x cubed minus 27. Okay. Well, we write 8x times a cube. As a cube, we say 2 raised to the power of 3 is 8. 2 times 2 is 4. 2 times 4 is 8. And x raised to the power of 3 is x. Okay. And 3 raised to the power of 3 is 27. So we've written that as difference of two cubes. Okay, now we apply our formula. What is x? X is 2x. What is b? What is y? Y is 3. So all we do is plug in for x, 2x, and y, we plug in 3, and we have our difference of two cubes factored. Okay? Okay. Good students derive formulas. They just don't memorize. And you may not think you need mathematics, but you do. And you may not think it's very important, but it is. I hope you learned something. Until next time. Thank you.